Hello and welcome back to the course on blockchain. And today we're going to have a visual demonstration of how blockchains work. So in order to follow along with the tutorial, you need to go to tools.superdatascience.com/blockchain/block. So at this URL, you'll be able to find all of the tools we're going to be using today. And right away, there's a copyright notice here. I just wanted to say a huge thank you to Anders Brownworth for making these codes available. You can, if you like them, you can also include them in your own websites. Here's the license agreement. All right, so this, we've already seen hash. So if you put in any information here, you'll see that this is the SHA-256 hash, which is calculated. Now here's a block. And as we discussed, it's got the block number, the nonce, the data, and the hash. We don't have the previous hash here because this is just a block by itself. And here you can see how the block works. So you put in any number. This illustrates the mining process. So for instance, let me just put in some value here. Kirill sent Adlan 900 AdCoins. Okay, and so you can see that right away it becomes red because it doesn't have a valid hash. So what we're going to do now is we're going to mine this block. So if you click mine here, there we go. So you can see that the nonce got updated and the hash got updated, and the block number and the data did not change. So that's, and you can see the leading zeros here. That indicates that it has passed a certain target difficulty, as we discussed. So it's small, it's less than a certain number. That's exactly what we talked about in the mining tutorial. So if you change anything here, so if you say not 900, but you say 901, right away the hash is absolutely different, and you need to mine this block again. And there you go, right away there's a nonce 21,505, gives a good hash. So go ahead and play around with this, and you can just see how this whole mining concept works. All right, so now we're going to move on to blockchain. And here you actually have a chain of these blocks, a proper blockchain. We have 5 blocks in it. And this time, as you can see, the new field has been included, the previous hash, the hash of the previous block. And as you can see, they're all cryptographically linked together. And moreover, each one of the blocks has a valid hash. So it's below that certain number. So it starts with the 4 leading zeros. And so let's have a look at what happens if we try to attack this blockchain. So for instance, if we try to change the value, let's say in this block. So for example, let's say we want to, well actually, let's say to start off, we're going to add some data, right? So we're going to say, hello, and then let's say I bought a house. Then we'll say, I don't know, how are you? Then we'll say my wallet number is X and 53, 54. It's just some random information. And then we'll just make the blockchain valid by mining all of these blocks, so we have something to start with, right? So let's give this a second. Sometimes they take longer because the hash might be further away. So let's try that one more time. There we go. Let's do this one again. Okay, that's all of them. And so now if we try to, so this is a blockchain and it's immutable, it's secure. What happens if we try to change something? So if I try to change something in this block today, right? How are you today? You can see what happens right away. So you can see that the previous hash doesn't change, it's the same, but the hash of the current block changes. And then so the interesting thing about this implementation that Anders has suggested is that here instantly this hash also changes and this hash also changes. And this is an assumption that once you attack this block, then you recalculate the hash here and you recalculate the hash here. You don't mine the blocks, but see, as we put in this value, the hash is automatically recalculated, and then so basically all of these hashes automatically recalculated. That doesn't have to necessarily be the case. in a blockchain, what could happen is just this hash, this previous hash would just be different and it would not match up with this hash, and that's where the link would be broken. So this would still be green, but inevitably you would still need to fix this, remind this, and then this would become red and you'd need to remind this. So I just wanted to point that out, that this is just a specific implementation where you can see that the hashes are recalculated automatically. So as I start typing in here, you can see this hash is recalculated, this hash, all the hashes of the future blocks are recalculated automatically. That's just the specifics of this implementation. In a normal blockchain, what would happen is this hash is recalculated and it would just not match up with this hash. And then this hash would not match up. This hash would still match up, but once you recalculate, remind this block and then remind this block, then these two would not match up. So that's just something to keep in mind. That's how it works. But yeah, as you could see, once you try to change something here, everything in the future breaks. Okay, and now we're moving on to distributed. And here we have the same blockchain, but it is with separate peers. So peer A has a copy, peer B has a copy, peer C has a copy. And so here we're just going to have a look at what we discussed in that peer-to-peer, distributed peer-to-peer network tutorial, where if we put in some value here, not only does the hacker have to now remind this block, and then this block, and then this block, but also the blockchain is secure because this will no longer match up, as we'll see. Just let's give it a second. It's still processing. It's probably going to have like a big number here. There we go. So now it will no longer match up. So if you look at the hash over here, you can see it starts with 4 zeros and then FADB, and here it's different, E4B9, and here it's E4B9. So we know right away that because the majority of blocks have the same hash, E4B9, something is wrong in this blockchain. And that's what we talked about in the peer-to-peer distributed network tutorial, that it's much harder to attack a blockchain that's distributed, because not only do you have to recalculate all of these, you have to also attack all of these blocks at the same time and all of these blocks at the same time before they're able to update this. And the more you have peers in the network, the harder it is. And finally, moving on to tokens, this is the same thing, but here we have transactions. So it just illustrates the concept even further, that you have the blockchain that is distributed across 3 peers. And then if you try to change like even let's say $1 from $97.13 to $98, so you can see right away these become invalid. You have to mine the block again, and then right away you can tell just by looking at the hash, it starts 6F5A, and this one is different. This is BAA0, and here you have BAA0. So you can see right away that this is the correct copy of the blockchain. Yes, and this is the incorrect copy. This is something is wrong here. You don't even need to compare all of the values and look for this one fraudulent transaction. You can just say right away. All right, so that's how tokens work. That's how basically the blockchain works with money. We're going to look at this one as well, even though we haven't discussed it yet. This is something that we'll talk about in module 2, but nevertheless this will be helpful in the future. So Coinbase is where actually the money originates. For instance, Bitcoins, once a block is mined, that is the Coinbase. So at the top of every block in Bitcoin, you'll see that that's how much money the miner got. And so this will allow money to actually be injected into the blockchain, into the system. Where does it come from in the first place? It can't come from thin air. And so you see the money is coming into the system through Coinbase, and then the transactions are happening, then that money is being distributed. Again, it's just another type of transaction that's included here. The rest of the principles are exactly the same. Again, that will be useful in part 2, in module 2 of the course. So there you go, that's the blockchain demo. I hope you enjoyed today's tutorial. Have a play around with it. Again, it's at tools.superdatascience.com/blockchain/ whichever one you want to start with. The easiest one is probably block because it's shorter to type. And on that note, thank you so much for being here today. I look forward to seeing you next time. Until then, enjoy blockchains.